We'll directly start with the agenda. So we'll first talk about what is cloud native, why cloud native, and then we'll be starting with Kubernetes 101. We'll tell the basics of that. We'll discuss how you can actually create those YAML scripts to deploy your application services, managing the databases and other parts. We'll also tell how you will be able to see the pods, services, and other parts of Kubernetes. After that, we'll be jumping into what all challenges will you be facing when you are using Kubernetes in the production environment. And later on, after that, we'll be telling you about how Zop simplifies all of that thing for you and how you can use Zop to up your game. Over to you, Piyush.
Okay. So cloud native. So sometimes like the traditional DevOps deployment strategies can be uh, cannot be scalable. So cloud native helps us to deploy our feature fastly and in a scalable manner. So it's the foundation of modern infrastructure and team velocity, which embraces container, microservices, DevOps, and automation. So it ensures that our services or microservices are deployed in a scalable manner. So Kubernetes. So Kubernetes is a cloud container orchestration platform which help us manage our containers, deploy them in a smooth manner, and it ensures that our containers are vertical and horizontal scalable. So like we don't face any downtime, or we don't have to manually manage our container based on the requests that we are getting on our website or our APIs. So the key concepts of containers are like pods. So pods are you can say it as the smallest unit of Kubernetes. So you can see as pods as the group of a container and some configs. So it runs the container inside it and provides some configs that are attached to to the containers, or you can say it as services or Docker images. Then we have deployments. Deployment is a type of controller in Kubernetes. So basically, it controls the number of replicas running for a pod. So it controls how pods are deployed and how pods are running inside the Kubernetes cluster. Then comes services. So services help us expose our pods on a single host so that we can access it based on the service name or any ingress. So basically, service help us expose the pods internally in the cluster, and ingress help us expose it to the internet. And coming to the namespace is basically a logical separation of your resources created on Kubernetes. So, like if you want to separate and filter out your resources based on any labels, like if you have a two application named website, and then we have something for marketing, so we can separate them into namespaces like website and marketing. So the marketing team can filter out their resources, and the tech team can filter out their resources. And coming to the Kubernetes architecture, basically Kubernetes follow master slave architecture, basically where we have control plane and some worker nodes. So in control plane, most of the it's the brain of Kubernetes. So most of the processing and all happens in the control plane only. So we have API servers. So API servers, you can say it as a front end of the Kubernetes, where every request is made through API server. So if you want to interact to a Kubernetes cluster, your request will be you will be forwarded to API server, then it will handle it and forward it request to wherever it has to go. Then come etcd. So etcd is a key store database. So it's a distributed key store database which stores the current state of Kubernetes cluster and its configs. Then we have controller manager. So as I told, deployment as a type of controller. So we have multiple controller types, and the controller manager manages how the pod should be deployed and what state the pod should be running in. Then we have scheduler. So scheduler help us deploy our pods, or deploy our pods on the worker node. So decide which pod has to be deployed on which worker node. If the worker node 2 has a memory, like it's at least 80% or 90% of its memory utilization, then it can say let's deploy it on the worker node, as it has less memory utilization and all of those things. Then we coming to the worker node. First we have a kubelet. So it interacts with the API server and it gets the information on how to manage those pods that running in this worker node. So basically it's managing the worker nodes in this, managing the pods in this worker node. Then we have kubeproxy. Kubeproxy basically used for network part of Kubernetes. So how it stores the IPs of all the services and how to like the internal host of the cluster. So it handles how a request will be forwarded to which pod, which service and all. Then we have container runtime. Basically, it's a runtime on which we can run our containers. So it can be Docker container D, which runs Docker images and all. Then we have pods. So before we have, I have already told pod is the smallest part. You can say smallest unit of Kubernetes cluster, which runs our applications. Then coming to a scalable production service. So what should be there in a scalable production service? So first, it should have a controller like deployment. So it's manage how pods are like deployed. The minimum replicas should be maintained and how our updates are going through for the particular service. So if we update the service image or releases it today, so it helps us like help us configure like it should have no downtime. Like it should be a rolling update. First, the new pod should come up and then the older pod should get destroyed. Then we have config maps. So config maps are secret. You can say it as we can store any config like environment variables or any secret that is required for the pods to run. So that all goes into config map. Then we have some storage resources. Storage resources basically a persistent volume. So if our pods require a persistent or our application requires a persistent volume to run itself, we can define a persistent volume and attach to a deployment. Then we have database resources. It's basically any SQL, NoSQL or Redis or cache data store that our application can use. Then coming to HPA, it's basically horizontal pod autoscaler. So it manages the horizontal pod autoscaling of our application or the controller that or deployment that we have. So basically in this we can configure min replicas, max replicas and some condition based on which it will scale up or scale down. So we can set up like memory utilization, CPU utilization to some percentage, and it will read the metrics, and it will help us set up those autoscale or downscale the pods. Then we have PTB. It's like basically pod disruption budget. So basically, if we have a production service, so we don't want it to have zero pods at any given time. So we can define the minimum number of pods that should be running all the time in PTP. So it manages that and it makes sure that at least one pod is available for that service in any given time. Then we have a service. Basically, a Kubernetes services just help us to expose the pods. So if we create normal pods, it will have each pod will have its each IP, and every time we deploy a new pod will come, the IP will change. So for communicating to it, if we want to communicate directly to pod, we'll have to make sure we are changing or updating the IP every time the pods are created. And so we have service. So what it does, it provides us like permanent IP to it, attaches a permanent IP to itself. So whatever time a service is there, it will be having a permanent IP, and we can directly send request to a service. Then we can attach some pods to the service, and like it will forward those requests to the pods based on the round robin format. So that we just have to know the service host or service IP, and we can make requests. So even the new pods come up, we don't have to change our host. Then we have ingress. So basically, services for exposing the pods or our application internally in the Kubernetes cluster. What ingress does is exposes it to the internet. So any request, if we want to make any request from internet to our application, we can define a host in the ingress like Zop.dev, Google.com, anything, and attach it to a service. So whenever that host is we hit that host from internet, it will forward that request to service, and that service will forward it to our pods. Then we have monitoring. So basically monitoring is required to monitor the health of our application that we have deployed, or see the performance log from the performance of our service or application. Then we can set up a like I will just give you a demo like for setting up Kubernetes cluster in my local. So I have already installed a Minikube in my local. So I'll just go through how we can deploy a service in a Kubernetes cluster. So in Kubernetes cluster, we have some manifest file, which are basically YAML, in which we define the configuration or the resources which we are gonna uh, deploy in the Kubernetes cluster. So can start with the namespace. So we will create a namespace first, so we can isolate or isolate our resources created for this demo app. So we'll just do kubectl apply the -f, and the file name we want to I have to change the directory. And the file name that in which we have defined the resource that we want to use. In this we have we can have to start Minikube. So it will spin up the Kubernetes cluster in my local, the Minikube start command, and then we can deploy the resources. Yeah. So okay. So if you see, it will create a demo app namespace. We can check it with Kubernetes kubectl get namespaces command. It will list all the namespaces in that Kubernetes cluster. So you can see we have a demo app here. Then we will create a config map. Basically, in config map, we have to define the in the Kubernetes manifest the kind of the resource that we are giving the configuration for. Then we metadata. Basically, we have the name for that resource and some the namespace in which it's gonna deployed and some labels attached to it. In the config map, we can define data. I have defined some environment variables like app name, environment, log level, and all. So I will just create it. And done. We can define the namespace in kubectl command by giving -end. So it will deploy the resources on that namespace. So now if we do kubectl get on big maps namespace demo app generated, we can see like it has created a hello API env config map with the whatever name we gave. It created one, and we can even describe it and see what's inside it using the describe command. Name, just have to do describe config map and give the name of the config map, and it will just show us what inside it. So its data has log level info, like whatever we provided, app name, and the environment. Now coming up with deployment, basically it's a controller which in which we can specify the number of replicas that should be running. Uh, then we have the spec for containers, like the Docker container that we want to run. For that spec, we can provide the image and the name for that container, and we then provide the ports so that it will expose that controller will that each pod will expose these ports. So we have given at 8,000 on which our sample API runs, and a metrics port on which the sample API exports the metrics. Then we have defined that env from config map reference. So whatever config map we have created, we can specify that, and it will read the environment from this config map. Then we have defined the resources. So what resources means, like it will assign itself 100 millicore CPU and 128 MI of memory. Like this is request. So this is the minimum requirement from CPU and memory that should be there for this pods to get deployed. And on the limits, we can define the CPU and memory. If it reaches the memory limit we have provided, the pod will restart. And if it reaches the CPU level that we have provided, then the CPU will throttle. We can also define some liveness or readiness probe. So whenever pods or container starts, the Kubernetes will hit this endpoint, the path we have provided on this port, and it will check if pods are up or not. So if we deployed some, like we have released some API that has some that's not able to start, so it will check it if the pods are running or not, and then only it will destroy the previous pods that were running. So we will not face any downtime in our services. So let's apply this also. So now we have deployed, we should be able to see the pods that were created for this controller. Right. So you can see it is running the 2 pods for this deployment that we have specified with the given image, Zop.dev sample go API. If we just describe it, you will be able to see it configs. And describe any one of these. So you can see the event that got triggered. So first it started the container that it first successfully pulled the image to Minikube, then created the container with that image and then started the container. So it will be running this image inside it. So each pod will have this image, and we can see the image that in the pods that we have given, and we can see the readiness and liveness prop configs also, and the environment variables that like it has to take from, like hello API and we config map. We can also see the deployment that got created. Yeah, you can see the hello API deployment. We gave this name and it has created it. And it's two pods are running, and the requested state was also two pods. Then we can go to service. So basically in service, we define again the kind as service, name, hello API, and some labels. And then we define the spec. So basically service are of 3 types: clustered IP, node port, and external name. So node port basically assign a port in the port to the service inside the node, which we can use to access it. And then cluster IP assigns a cluster IP, which can be only used internally for communicating with that service. And externally, we provide some domain to the service, so which we can use to communicate from externally from the cluster to the service. In this way, then we define the ports. So we can name the port as HTTP port, and we define the port. So if we hit a service with 80 port, it will go to the target port as 8000. So we defined 8000 as a in our deployment as port on which our API is running. So any request coming to the service 80 port will be redirected to ports 8000 ports. And then same, we have defined metrics ports also. And in selector, we have a label. So whatever label we have given here in our like in our deployment, each pod will have that label, and the service will match that label based on the selector given here, and forward the request to the through those ports. So when we create a service, it matches the labels provided in the selector, and it knows on which pod it has to forward requests. So let's create a service also. So it has created a service. We can see again the service created using kubectl command. Yeah. So it has created a service on cluster IP this. and these are the pods that are like we have defined inside it. Then we can go to ingress, but before going to ingress, we will just install a Nginx ingress controller in a cluster so it can manage that ingress. So before that, like we have defined many YAMLs here, so we have to apply it one by one. So we have something called Helm. So Helm charts are basically a package manager for Kubernetes, which are combination, like which stores all the templates for all the templates, which you can call the manifest files, inside a single Helm chart. So whenever we want to install something, we just have to do one command, Helm install, and it will install all the manifest file at once. So it keeps our code dry, and we can provide like we can have a templating format in our templates. So whatever values we provide, it uses those values to install those resources. So a typical Helm chart directory structure looks like this: a chart.yaml where we define the metadata of the Helm chart, like name, version, and all, and dependencies and all. Then we have values.yaml where we can set some default values, that those if user doesn't provide any values for installing the Helm chart, then it will take those default values and install it. Then we have templates in which we define the YAMLs or the Kubernetes manifest. Okay. So we can deploy a Nginx Helm chart using this command. So first we will have, when we do Helm repo add, it fetches this repo and stores in a local with the alias in whatever we provide here. So the Helm repo add command works as we have to give alias and the source Helm chart that we have. So it stores that in local, and whenever we want to install it, we just have to do Helm install, uh, give the name of the Helm release that we is going to be installed in the Kubernetes cluster, then the alias we have fetched, like we have stored here, and the chart name of that Helm chart that we are going to install. And we have defined, we give the values.yaml file with hyphen values and namespace with hyphen namespace or hyphen n. So we already have a values file, you can see it as. So we are just giving this configs, and that will the Helm chart will take it and create manifest based on this. Okay, so we have to go it in that directory. Okay, so first we have to create a namespace. So like in which we want to install this Helm chart. It will take some time to install it because there are many resources or manifest file that are going to install. So it has installed it. You can see in the ingress controller has been installed, and we can see the pods kubectl, or get, we can do get all, or we can just go pods namespace that we have given here. Index. So you can see get pods. So you can see the Nginx controller pod running in the namespace ingress Nginx that we have installed to our Helm chart. Now we can go back. Now we can go back and create our ingress. So if you see ingress, so its kind is ingress, and like we have defined the ingress class name through which it will be controlled. So we have installed in the next ingress controller. So every request of that ingress will go through it, and it will map each ingress with a particular IP, like each host with a particular service. So you can see hello API.local is mapped to our service hello API, and it will forward the request based on the host to the particular service. So we can do kubectl apply nf. Uh, you can see it hasn't created an ingress. We can do it by doing kubectl ingress namespace demo. You can see that it has created the ingress, and we can even describe it if you want. You can play it and see the configuration of that particular ingress, like host, annotations, the rules, like it should forward this to hello API 80 port or hello API 2121 port. Then we have HPH. So basically HPH is for horizontal pod autoscaler. So in which we define min replicas, max replicas, metrics. You can say the condition based on which it will downscale or upscale the resources. So it has CPU, resource CPU and resource memory. So I have set here based on the CPU and the memory utilization, it will upgrade. So if the CPU or memory utilization goes above 80%, it will scale. It will scale the deployment, and like if two pods are running, it will make it 3 or 4 based on the utilization. And if the utilization comes down to 40, 30 or 60, it will downscale and reduce the pods to 2 again. And we can even do it. kubectl applies infinite 06 hp.yaml space. So it has created this HP, and so we have given a labels. Based on the labels, it will specify the deployment it has attached to the pods. Like the scale target, we have defined deployment and name as hello IP, so it will know that hello IP deployment it has to upscale or downscale. Then we can go to PDP, and you can see the PDP. We have defined the min available replica as 1, and it will, based on the selector, it will see which pod it has to make sure that there should be 1 replicas of that deployment has to be there. We can apply it also. F07 space. So it has created this also. Now we will, for monitoring purpose, we will install a Prometheus kube stack Helm chart. We will have Prometheus and Grafana. So for that, we just have to do this Helm repo add. I have already done in my local. So I already have the Prometheus community like Helm's data Helm chart source in my local. So I will just create a namespace, and I will do Helm install Prometheus Grafana. So it will install that Prometheus kube stack Helm chart in our Minikube cluster. Okay, so in values we have given something wrong. Max disruption. So we can go to the Prometheus kube stack Helm repository. And we can check its values.yaml. So what it requires and how it should be given. So we see here it should be given inside Prometheus spec. And Prometheus spec should should come under additional rule group, and
Excuse me, sir.
yes,
So am I audible?
yes, yes.
So can you use AI for these corrections?
What?
Like if we just upload this file in some AI, then it will autocorrect or suggest us the hands.
Yes, like it can do it. So, but it's a good practice to go through the documentation and like do it yourself. So you know how. So you will know how to like give these values. Okay. One second.
Okay. Uh, I am a backend and front-end full stack developer, so I often think that going to documentations, we only read those and try to find our stuff. And if it is our ultimate aim, then we can use AI for that only. Like it will boost our workflow.
Like you can use the AI, but like for at least the basic knowledge, you should go through the documentation to know how each thing work. Or if anything
Yes, sir.
breaks, if you use AI and anything breaks, then you won't be able to fix it. So the problem here is like we are still using these values, Nginx values. We were because we were in Nginx directory. We can switch to Prometheus and run this command again. It should work. And like we have already installed it. Like it has created a Helm release for it, so we can just do Helm upgrade. So it upgrade the existing Helm release with the values we are providing now. Yeah. So you can see it has upgraded it, and revision you can see it too, because when you install it, it failed at first, and it has uh, upgraded it in the second revision. So in Helm chart, it also stored the revision. So basically, you can see what changes you have done through a period of time on using the Helm chart. And if you do kubectl, get pods, namespace monitoring, you will be able to see uh, Prometheus Grafana pod running and Prometheus, some Prometheus Kubestack pods running. So Prometheus, why we installed Prometheus? So it help us collect the metrics of the Kubernetes cluster. So if our service is running in the Kubernetes cluster and we want to capture the metrics and store it in a permanent storage, so we can monitor our service at any given time over the period of time. Like we can see the behavior of it. So Prometheus is helpful for that. And for Grafana, it's basically a visualization tool where you can see all the metrics collected by Prometheus and create graphs based on it. So for collecting the metrics, we have to define something called service monitor for each service, where we'll define the uh, selector. Like it will see which service it has to fetch metrics from and from which endpoint it has to fetch. So we have defined here metrics port. So if we go back to our service, we have also a port named metrics port, which uses the 212 port our application on which it exports the metrics. So here it will see the service, it will get this port, and it will hit it on the port and collects the metrics. We can add simply -f 08 service monitor YAML, And one more use case of Prometheus is we can set up our alert based on the metrics using the Prometheus. So Prometheus has something called Alert Manager, which goes through Prometheus rules, like where we define the some rule based on the metrics. Like if this rule is breaking, then it will forward the alerts to our destination where we define, or it will trigger those alerts. So here you can see we have defined some expression where we have defined some metrics, or you can say PromQL query, based on which it will configure the alerts. So we can apply this also. Yeah, do it in demo app in space. So you can see has created it. Then we can export the Grafana port. So in our localhost 3000, and if we go to localhost 3000, it will ask for some password. So it will be the password that we have defined in our values.yaml in Grafana section. So basically it's admin123 and the username is admin. We can log in, we can go to explore. So you can see the data source as Prometheus. So whatever metrics Prometheus collects, we can visualize it here. So I will just show you one metrics that the sample API I have deployed exports, basically Go routines, and we can filter it based on the labels. And if I run this query, we'll get the values. So I've just started getting the metrics. So you can see that 9 Go routines are running in my service. Basically, using that, we can have dashboard where we have multiple queries and multiple graphs in one dashboard, and we can use it to monitor our services. I can close it. Now going back to the presentation, typical observability setup of a service requires basically a metrics exporter or metrics collector, which exports the metrics to some permanent storage or persistent storage, and a monitoring tool or visualization tool which help us to create dashboard or visualize those metrics. Then a logging agent which will be deployed in Kubernetes cluster, and it will collect logs and forward the logs to our observability stack like Loki, Elasticsearch and all. And again, Grafana can be used to visualize those logs. And we also need a tracing service. So it's basically tracing setup is implemented in applications using SDKs, and then we have to deploy open telemetry collector like Tempo or Jaggers, which collects those traces, and again that can be visualized on Grafana. So the challenges basically we face using Kubernetes or while deploying any production infrastructure is like we have to maintain a lots of YAML file. As you have seen, like I had 9 or 10 YAML files. Then we had some Helm chart, and we have to read through the documentation of those, how they work, and all the values. Like Prometheus had around 9,000, 10,000 lines of values.yaml file. We have to go through it. Secret management, like how are we going to manage a secret so it's not visible to any users or anything. It should be stored in a secure manner. Like then scaling, how our application is going to scale based on the request, memory utilization, CPU utilization, and also the observability and monitoring part. How are we going to observe it, monitor it, and based on the metrics, how are we going to fix our services? You can say based on the errors we are getting based on the CPU or CPU spike, memory spike, and cost control and governance also. So cost control, basically we have to minimize the cost of our infra, so without compromising the scalability and availability of our applications. And also the CI/CD complexity, how we are going to release those our code, and how it's going to be deployed in the infrastructure. Okay, so now I will forward it to RN. Like RN can take you through Zop.dev provides.
Thanks, Kyush. It was pretty tiring and it had a lot of things to understand and remember. That's where Zop.dev comes in. To go forward, Rakesh, should we take a break for 5 minutes and then start for the audience?
I think we're good to go.
Sure, great. Okay, so we'll start with I will just share it from my system because there are some things which are set up already. Just give me a minute.
Sure.
I hope my screen is visible to everyone and am I audible?
Yes.
Yes. Yeah, great. So, so whatever Piyush has talked about, right, and it required a lot of YAML files to maintain and a lot of things which needs to be pushed, and you need to set up a lot of things in your system as well, and it gets complex. So Zop allows you to do all of that stuff steps, making sure that you are compliant, and at the same time you are not losing control of your systems. You are having that control in your hand. So what Zop does is it allows you to manage your cloud providers, AWS, GCP, Azure, your Kubernetes cluster, with all of those setups which you need to do manually, and you might miss, you might not miss doing all of that. So in short, that the network and security, artifact registry, setup domains, IAM roles, load balancers, clusters, data stores, environments, observability, it provides you all of those things with just few clicks, and you are actually ready to go in just probably 30 minutes for your first cluster to go live. Along with that, you are also ready to deploy your applications with pre-built CI/CD pipelines, Docker images, and whatnot. You just need to configure it a bit for your systems. So rather than talking more about it and what all and what not it gives, we'll just backly dive into a small demo on what all the Zop platform provides and how you can do it. So once you log in into Zop, it is secure. You will be logged out if you are logged in before. Okay. So once you log into Zop, you will be on this particular screen where you are asked to add your cloud account. Uh, Zop supports GCP, AWS, Azure, and OCI. So for this particular example, we'll be connecting with our Google Cloud. So once you click on that, it takes you through the process, and you can actually just a few simple steps, and you are ready to connect. And you can choose the projects which you already have. I won't be able to connect this particular cloud account because I've already connected one in my account there. So this is a particular cloud account which is connected there. And I've also created a cluster because creating a cluster will take around 30 minutes because we set up a lot of different things. Uh, just to go there, I will just show you what all we do and what all you need to do. So once your cloud account is connected, you go and add cluster. It asks you for the cluster name and the region which you want to create in. Probably let's create a new cluster, Zop demo, and we click on create. So the cluster is being created. It will take some time to create. Meanwhile, I have already created one more cluster for you, which is Zop webinar, which you will be using. But before going into that, what all is happening behind the scenes. So as Piyush mentioned, he had to set up a lot of different things. Here, everything is automated. We will first create a VPC, we set up the private subnets. Since we already have those for this GCP 17 June on Zop webinar cluster, that will not be created for Zop demo, keeping in mind that you don't want to create resources which you don't use. The cloud NAT is set up, the firewalls are set up, and Artifactory is also created once you create any one cluster. Apart from that, the load balancer is always present in every cluster which is there. We create the cert managers such that you don't need to worry about creating your own domains or like setting up your own domains. You can set up your own domains, but for easy to go and from first start, you can just use the domains provided by the Zop. So since this cluster is being created, we can go to the audit log and we can see the jobs which are actually running here based on the cluster. So we have Zop demo run. There are 3 jobs created. We can actually go and see inside it what are the logs running, what is actually happening behind the scenes, what all Zop is doing. Meanwhile, we have already created a cluster, so we'll just jump into that and see what all options Zop provides. So we can actually change the machine type and minimum and maximum nodes. We can also install open cost in our cluster to see how the costs are happening. But before going into that, let's see how our cluster, so the things which we have created or even our cloud account, is it running fine? Is everything is there properly or not? So Zop provides you to just to audit your cloud account cluster. So just you need to run all and it will actually run everything for you. What all is there, what all is not there. So we'll just come back in few minutes to see the result of this. So yeah. It is actually pretty fast. We have already done it. So we can see that like 9 other things are in danger, 17 are compliant, 9 are warning, and 4 are pending. With just probably one click and like few seconds, you are able to get all of those details. Uh, if this would not have been there, but you would be actually wasting a lot of resources maybe, and you would not know what is going wrong and what is not going wrong. So it's just a mirror to your cloud account. So we have not created any SQL, so we have not enabled it. Probably that's why it's in danger. Similarly for the cloud storage and IAM principles as well. Going back, once your cloud account is created and you have actually connected your cluster as well, you go to the applications page. Applications are basically nothing but you can separate based on your needs, like how you want to actually divide your teams. Maybe if you have some backend team, front end team, you can create different applications for them. You can start by starting from an NP project where you will be actually be given a form where you can choose which cluster you want to do. So Zop webinar is a cluster which is already created. We can also use Zop demo. It will smartly automatically create the application once the cluster creation is done, or you can even start creating a new cluster directly from here itself. So since we have Zop webinar already, so we'll give it an application name like workshop demo. We can even create different environments for it. But for now, let's not create environments. Let's keep it simple. So application name, workshop demo, and then we click on create. Meanwhile, when workshop demo is being created, it is actually creating a different namespace in your Kubernetes cluster. So I will just open the lens and I will show you what is happening behind the scenes. So this is a workshop which is already present there, and workshop demo is being created. And we can also see from the audit log itself, like what is actually happening inside the application, how is an issue being created, what is all is happening. So let's wait for a few minutes. Meanwhile, let's come back to the lens and see what all actually Zop did. So apart from workshop, everything is created by Zop. Okay, let's see this. So Zop has actually automatically configured our secret store, Prometheus, which Piyush took a lot of time to configure, which has been done in like few minutes. NetT for network, and then we have kubeproxy, kubemanagement API, and kubedns. We also have something like FluentBit already installed, cert managers to manage the certificates for the domains which is being created. Uh, we also have the API which we created. We'll come back to how and what happens with the APIs. So we can see that this particular job got completed. And if I just refresh the lens, I can see that the workshop demo namespace has already been created. Coming back, we can also create a service directly. Let's name it demo. And we Zop give you option to create either a default host or a custom host. So default host is basically a Zop.dev domain with some UID in the beginning and the name of the application with the name of the namespace which you have created, the application which you have created. So once we click on create, it will actually start creating this particular demo using a Helm chart, uh, which is actually open source repo. We'll talk about it later as we go to the end. So since this is getting created, you can again go to the audit logs and see what all is happening, how it is created, what not is happening. And once it is actually created, you will see an ingress endpoint. It will again take a few minutes. So, but let's come back here and see what is happening here. So we can see that there is a API service which I have already created, and there's another Gopher service which I've already created. So let's go to the API service and see what all is there. So it actually gives me hello, welcome to APIs. But it's not just that the service is getting deployed. So this particular Gopher service is actually from this particular repo or another Zop webinar where I actually copied this deployment guidelines provided by Zop platform, which tells you to set up your GitHub secrets. You can actually automatically integrate, or you can copy the credentials from here and save it there. And you need to copy this workflow file and the Docker image. Once you are done with that, we push it on the code. I just did it 24 minutes ago while Piyush was actually telling you guys about everything. So we go to the actions and we see that the action Dockerized our code, deployed our code. And if we come back to the Gopher service, we can see that the application name is updated. So it is the Gopher service application which we deployed right now. Meanwhile, when a new application is created, which actually got created while I was showing you what I did earlier, the sample API Go was actually deployed. So we can also hit this particular endpoint and see what all is happening here. So it will actually give us hello, welcome to dem. It's a different service, but it's a default image which Zop.dev provides already when you create a service. You can manage your HTTP ports, metrics ports from here. You can enable basic auth on your particular website. So if you do that, it will actually ask for a password when you open that. Meanwhile, let's try doing that. And you can also give the health check endpoint so that the Kubernetes know that your service is alive and ready. So maybe let's give a Kubernetes an endpoint. Let's give this slash. So since it's a Gopher application, it would have your well-known slash alive, which actually gives us a status up. Let's copy this endpoint and let's put it here. Okay. And we can also, so once we give the health check endpoint, it asks for initial delay, how much you want to keep, if you want to keep a timeout, if you want to keep a failure threshold and period. Once this is done, you can actually save it. And once the application restarts, it will actually have all of these values to check from. Oh, okay. You can also manage the resources which Piyush was telling to manage a YAML file where you will manage all of that manually. You can actually set it directly here by keeping the values. The units are same throughout, and you can set what threshold you want to keep. Uh, Similarly, there is data sources we can add. We can connect PubSub here directly. It will automatically inject a Google GCP credentials in your application, which you can read from your application code. But we'll just see a small demo of how MySQL is connected. We'll come to that. But it also allows you to set up your environment variables. You can give your key value pairs. If it is a secret, you can set a secret here. Meanwhile, since it is actually updating the health check endpoint details, it is not letting me do anything because it is happening. Something is happening behind the scenes. So let's see what is happening here. Okay, it is installing something. Okay, we'll come back here later. But we can see, like, you can add a secret and it will be, Kubernetes secret will be base64 encoded or a custom encryption if you want to. And you will not be able to access or modify that value. You can not be able to actually see that value later, but you can actually modify that value if you need to. So, coming back, we can also see that, like, we just deployed a service right now. It was a sample application. We are actually getting all the logs from the application when the application started, and it is actually hitting some endpoint for some data, which is actually the remote log level change endpoint. So you can actually change the log level of our application. So if you see here, the logs actually have info logs coming a lot of times. Let's change it to probably uh, error, and we'll stop seeing all the info logs, new info logs. Whatever is already there will be there, but now new logs will not come. We can similarly change it to debug, and we'll see a lot more logs than what we saw before. So we can just wait for a few seconds and we'll start seeing that. Okay, the server actually restarted now because we have made some changes in the service, but let's see what all is happening. Okay, so we got a message that log level updated from info to debug. And now we are actually seeing a lot of more logs again. We can again go back and switch off, but let's see the metrics part. So whatever is happening inside the application CPU utilization, network utilization, even the memory utilization, we can see from the metrics board. These are all provided by Kubernetes. And then we have Nginx ingress volume controller. Uh, so if we refresh this, so since we enabled the basic auth there, we are now getting a username and password to put, and our job is completed. So if we go inside the service, we actually have the credentials present here. We just copy it, put it, and we are actually added basic auth with just a go. I think Piyush would be jealous seeing me doing all of this with just few clicks, and he was actually writing YAML for all of this. But okay. Okay, coming back to logs metrics we saw, the Zop actually also provides you alerts. So you can actually see the status of what is happening right now. If something goes bad, the status will change, and you can actually configure these alerts to come to you maybe on your Google Chat or Teams or Slack. You can see what type of alerts you want. Do you want info alerts, or just critical alerts which needs actually your attention? You can set the channel ID, webhook URL, and you can just start getting all of these alerts in your required platform. And we'll come to that too now. I just showed you services, how you can manage those, and what more it provides rather than just actually deploying the service and hitting the URL. It provides you the complete observability present inside. It also provides you all of these features in a cron job. You can actually just give a name, give a schedule time, and it will actually create a cron job for you. New cron, and we'll give some schedule, and we just create it. It will again provision everything for that. The jobs will run, and this cron will run at the required time. And all the similar features are actually available here as well. We can actually change the schedule time and different concurrency policies if you want to have. Now, the most interesting part is the data stores. So you can actually just, with a few clicks, maybe create a data store in GCP or have a data store in cluster if you want to actually use it probably for a dev or a QA environment where you don't want to actually provision a lot of resources and you can just use an in cluster database. You just click on that, you give the name, you give the configurations, and it actually creates a data store. I'll show you that already, which I have created in the workshop application, which I created earlier. So I've actually created a API DB and I have attached my API service with a DB name users. It's not just that my service is connected. Uh, but I can also see the logs of the database which was present. So it's set to actually debug level, and there are a lot of different things which is happening. Similarly, we have metrics for our in-cluster DB again, which actually is telling me how many aborted connections were there, how much bytes it received, how much bytes per second it is getting, and the buffer pool it has. It is the in-use connections, and if the MySQL was down at any time, it would just drop back to 0. Since there were some connections being made, so that is why the open connections which we have is 3. And like similar to this, most of the databases have these metrics logs available to you. Similarly, you can also set alerts for your in-cluster database, uh, and you get all of these alerts in your dashboard. You can also set permissions at application level. Uh, Suppose I want to give Piyush permission for this particular application, I can just add it. And once I click on add, he will be able to access all the applications with the IAM roles as well. So this all of this observability which I was seeing was just present in my application. But what if I want to actually have all of this observability data go somewhere else? Okay. So I actually have some new relic created, uh, and I can actually send the data, or I can create a new destination as well, which is one is the Zop provide. It provides you an observability cluster, which is again yours. You will be charged something like what Datadog and all of those charge you. It is just on your cloud account, and Zop doesn't charge it. It is completely built on the open source products available out there, and I can just connect these clusters which I have created right to these. Oh, okay, sorry. I can create a new cluster of myself. I can choose which account I want to create it in. Uh, I can create a new cluster. I can choose if in my existing cluster itself, if it wants to set up. And if I click on create, it will actually start sending all the data there. Meanwhile, let's see if the cluster which we created in the beginning is created or not. Okay. So Zop demo was the one which I started in the earlier, which is actually now created. Meanwhile, I was just giving you the demo of how everything works. Uh, so that is pretty much it. What all Zop provides, it's pretty fast. Like we covered everything in less amount of time, uh, with the similar things and a lot of things what we were doing. So obviously, it was a fast setup. We were able to launch our clusters and applications in less than 30 minutes. The cluster was also ready, and the applications you also see, like we took actually 2 minutes maybe to set up everything. Coming to that, so how you can use it. So as a developer, rather than waiting for infra request, you can actually start like creating your own infrastructure from scratch, probably in 30 minutes, and you are ready to push your freelancing projects or even your production workload, and will make sure that you are able to handle the traffic which is happening there. Uh, if you are facing some operational issues, you can actually give access to the developers directly, and they can actually manage their infrastructure with just a few clicks. And you will be able to actually see what all costs are happening, how much you are spending, and everything from the cost and audit dashboards. That is pretty much from our side. We are open to questions, and we would welcome you to join the Discord community of SOP and talk about DevOps and everything else.
Do you guys have any questions? You can paste it in chat or like ask us.
So, someone has asked, my query is why Kubernetes above all other alternatives that we use, is above all the other alternatives that we use.
So like if we use any VM instances to deploy our like application, it will not be a cost effective way if we set up the auto scaling part, or like we will deploy one application in one VM instances, and then we have to use a load balancer for each VM. Then for auto scaling also we have to do different configuration, like external configuration for auto scaling, and auto scaling will be not based on container, will be based on VM instances. So you will auto scale instance, not your containers. In Kubernetes, like you can deploy multiple pods or multiple servers in same VM or nodes, and the auto scaling is based on like your pods, not on the nodes. Or like nodes are also auto scale, but if the resources of that particular application reaches, you can just auto scale pods. And for load balancer part also, we will have only one load balancer attached to a cluster, so we don't need multiple load balancer for each VM instance or each application.
Great. We have another question from Anu.
Okay.
Does it support cluster upgrade as well?
Yes, like Zop.dev, like the cluster version, like the whatever cloud provider provides, we support automatic updates for those. So the nodes will automatically be upgraded to the newest or the latest Kubernetes version. Or if you want to upgrade the type of the machine, like you can upgrade it from Zop.dev, like our dashboard.
So, Kamakshi has asked, could you please elaborate what actually Zopdev offers?
Okay. So what all we did right now, right? What Piyush actually used Helm charts and Terraform scripts to create the cluster and all of those things, right? We did the same thing using Zop, but the things were pretty much more understandable and it was much more developer friendly. Rather than me knowing everything about how all everything works in the DevOps world, I was easily able to create a cluster, deploy an application, see the logs, metrics, and actually update the resources as well, enable basic auth. So Zop provides you everything packed in at one place, from where you can quickly start and boost the developer experience, and you can actually easily deploy your applications very fast. So that is what Zop is and what Zop provides.
Okay, perfect. And I think there's another DM that I've received. Let me just read it out. So, someone's asked, what are some common mistakes teams make when trying to run Kubernetes in production and how can they be avoided?
Like some common mistakes are like over provisioning resources. Like for node we can provision more memory or CPU, so like the resources are not utilized, still we are paying for the over provision machines or the containers or the services that we are using. So that can be provisioned based on the metrics, like we can see what how much CPU or memory utilization is there on our in our cluster or our application, and based on that we can like configure it, the machine and all. The second is like the provisioning of like some secret management. Like we like we can have some mistakes in managing our environment for production and stay, like when we are maintaining multiple environments, we can sometimes we can mix up the environments, and so it will affect the how our application is running on prod and stage. uh, and we can also like make mistakes, like common mistakes in while creating the manifest or the helm chart, while providing values, like how to configure it, indentation and all, we have to take care of that and all.
Okay. And there's a question from Nikhil. If some developer wants to learn DevOps using Zop, then what should be the path?
So the past should be that you sign up, you connect it louder and you start exploring. That is the pretty best way to explore something, because it is not something for that which you need a lot of documentation. Still, we have the documentation on our website, zop.dev/talks. Maybe we can share that in the chat itself. Uh, so you can refer that. But I would say rather than doing that, you can just actually hop on, sign up, connect your cloud account, probably as a personal user, you will be able to get a free cloud account on GCP, AWS, or anything for a trial version, and you can start exploring it. And let us know how you feel and what all we can do to improve your experience.
What are the must-have tools or add-ons you recommend for observability and monitoring in a production Kubernetes setup?
So like it should at least have a visualization tool like Grafana, storage tool, like a metric storage tool like Mimir, or you can have Cortex where we can store our like metrics for like long terms, like for 1 year, 2 years, and so we can have a trend. We can see the trend based on trends. We can predict many things, and a tool to collect those metrics and like remote write those metrics to the storage. So basically, just like Prometheus, how it Prometheus help us to scrape the metrics from the services that from the services and store it in a persistent storage or remote write to any persistent storage that user can provide. Then we must have a log collector like Fluentbit, which runs on each nodes and collect the logs of each services and then export it to some storage. So we also need something like Loki to store those logs. So basically, Fluentbit will collect it and then sends the logs to a storage like Loki. And then for traces, like we can have something like Tempo, which stores those spans and traces. And again, the Grafana or any visualization tool can be used to visualize how the traces and spans, like what time each request is taking and where it has taken those times. So basically, these six components, like a visualization tool, a tool to collect metrics and export a remote write to somewhere, a tool to collect logs and export it to a storage, then a tool for storing metrics, tool for storing logs, and for storing tempo.
So, okay, thanks everybody for being here and thanks to our speakers for this session. Have a great evening ahead.
Thank you, Rocky, for arranging everything.
Thank you so much.
Thank you. Thank you, everyone.